Hi folks, Dr. P here. We're going to be doing linear scale factors. Determine the linear scale factor for each of the following scenarios to provide your answer as a ratio, a quotient, and as a percentage to the nearest hundredth. In scenario A, the perimeter of a triangle increased from 5 centimeters to 7.5 centimeters. So we're talking about an enlargement here, and going from 5 to 7.5 centimeters. So it's an enlargement. And we know that for an enlargement, the linear scale factor will be larger than 1. We are going from 5 centimeters. So this is the old, or the original. We're going to call it old here. This is what we're starting with. And we're ending up with a perimeter of 7.5. This is the new. We're going to be using the linear scale factor formula here in both example A and B. So the linear scale factor formula is the dimensions of the new object divided by the dimensions of the old object. So in this example here, our linear scale factor, the new object is 7.5. The original, the old one, is 5 centimeters. Now this is a quotient, and they want us to provide an answer in 3 different formats, one of them being a quotient. However, we cannot provide or have a decimal in a quotient, so we need to get rid of the 7.5, and this can be done in different ways, but one way would be to multiply, for example, the numerator by 2, the denominator by 2. We could also multiply numerator and denominator by 10. You would achieve the same purpose here. And if we do that, 7.5 times 2 is 15. 5 times 2 is 10. Then we can divide numerator and denominator by 5. So it's going to be 15 divided by 5 is 3. 10 divided by 5 is 2. So this is our linear scale factor as a quotient. They also want the answer as a ratio. That would simply be 3 to 2. That's our linear scale factor as a ratio. And then finally, as a percentage. So we would divide 3 divided by 2, which is 1.5, and multiply it by 100. So it's 3 divided by 2 times 100, and that equals to 150%. So it's clearly an enlargement. That's A. In B, Edmonton is approximately 300 kilometers from Calgary. On a map of Alberta, the cities are 5 centimeters apart. So the first challenge here is going to be that we're dealing with different units. We are dealing with kilometers. That's the actual distance, 300 kilometers. And then we have centimeters. That's the distance on the map. We need to work with the same units. Now, you have a few options here. You can convert the kilometers to centimeters or the centimeters to kilometers. Doesn't really matter how you do it. The second option here is that we can go ahead and do the division. Well, the division has to happen, or the conversion has to happen first, so that's not an option. So what we're going to do here is in B, we're going to convert, let's say we convert kilometers to centimeters. So we're going to convert kilometers first to meters, and then from meters to centimeters. We have 300 kilometers. Every kilometer consists of 1,000 meters, so we have to multiply it by 1,000. And every meter consists of 100 centimeters, so we multiply it by 100. So this is going to give us 30 million centimeters. Now we can go ahead and use the linear scale factor formula. So the linear scale factor, so the nu is going to be the size on the map. So on the map they were 5 centimeters apart. In reality they were 30 million centimeters apart. We can reduce this quotient. We can divide numerator and denominator by 5. 5 divided by 5 is 1. 30 million divided by 5 is 6 million. So that's our linear scale factor as a quotient. As a ratio, it's simply 1 to 6 million, which is, this is the format that usually is used on maps. I think there's an extra 0 there. That. And then also as a percentage, this is going to be a very small percentage, but it's a very, very large reduction. So it's going to be 1 over 6 million. We do the division, and then we multiply by 100. And that's going to give us 0.00017%. That's a wrap. Until next time, may the math be with you.